Today you're responsible for the last 12 questions of review. So grab your review from yesterday, which I asked you to print if possible, and let's take a look at a few together. So of the second 12, the first one I want to look at together is 16. So turn to 16 with me. It says Mike solved the multiplication problem below using an area model. I love area models. We use them all the time in problem solving. Complete the model to find the product. Product means we need to do what? Multiply. It's the answer to multiplication. Find the product and then write the equation with the final product. All right, so we're going to distribute the 7 times, we're going to distribute it to 40. 40 plus 7 is 47. So this is just our equation, okay? This is what they expanded here in the area model. So we're first going to take our 7, and we're going to distribute it to the tens place. So we're going to say 40 times 7. 7 times 0 is 0. 7 times 4 is 28. Then I'm going to take my 7 and distribute it to the ones place. So I have 7 times 7 is 49. Now, if this is partial product and this is partial product, how do you find the total product? You put them together. So I have 280 plus 49. 0 and 9 makes 9. 8, count up 4, 9, 10, 11, 12. Regroup to the hundreds. And 1 plus 2 is 3. So I think it's 329. My apologies. I'm going to use standard algorithm to check it. 7 times 7 is 49. Regroup to the tens, just as if you were adding. 7 times 4 is 28, plus the 4 I regrouped, so 28, 29, 30, 31, 32. Do our answers match? Yep, check. I'm always checking my work. All right, but now they want us to write equations with a final. Well, the reason I love area models so much is because it helps make distributive property make sense. So let's take a look at the equation in our first box. That's 40 times 7 plus, so we add our two partial products. What's equations in the second box? 7 times 7. So then what was 40 times 7? That's 280 plus 7 times 7 was 49. So there's our two partial products, and that equals 329. So there you have it. All right, number 17 is the next one to look at together. It says, Freddie sketched an array. Array means groups or rows and columns to represent a multiplication problem as shown. What is the final product? Again, product means you need to multiply. What is the final product for this multiplication problem? Well, let's see how many rows go across. There's 1, 2, 3, 4, 5, 6. So there's 6 rows. And how many are in each row? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is 6 rows of 18. So back when we did our basic facts, we said 6 times 18. 6 represents your rows. 18 represents in how many's in each. And we reach for the product. So how many in all? So I have 18 times 6. 6 times 8 is 48. Regroup to the tens. 6 times 1 is 6, plus the 4 regroup makes a 10. So 108. So our product, our final product, is 108. Now, is that a decimal number or is that a whole number? That's a whole number. There is no decimal. So before the decimal, 108, nothing after the decimal. So that'd be 108. I kept it in the box, nice and dark. All right, the next one I want us to look at is number 19, geometry. A figure is shown below. Which two line segments do not? If it's a not question, you must use T's for true and S for false. Do not appear to be perpendicular. Remember, perfect cross. So I have perpendicular, big L-A-R. Because perpendicular makes that right angle. It makes the perfect cross. Okay? So see, line segment CD. So right here, CD and DE. Now, I have a little checker that I'd use for right angles, okay? It's just a little Post-it note. And I put my corner in that vertex here. Did that make the perfect L, that perfect cross? Yes. So here is my symbol for a right angle. And if it's a right angle, it is perpendicular. So this one is true. They are perpendicular, so it can't be our choice. Line segment DE. So this one again right here, DE and FE right here. So we have this vertex right here. Let's see. I'm going to put it in here. Oh, this one is more. Look right here. It's more than a right. So that one's obtuse. So that one's false. It is not perpendicular. So that one is a possibility. Line segment AG. So I have AG here with FG. So with FG here. Well, that looks perfectly vertical and this looks perfectly horizontal. So I'm thinking it will. I do my little tester here. Did that fit perfectly in that corner? Sure does. So go ahead and write my symbol for a right angle. And if it's a right angle, it is perpendicular. So that one is true, therefore not it. Line segment AB, okay, says that perfect horizontal one here. And CB right here. So I'm going to test this vertice right here. Did it fit in there perfectly? Absolutely. That perfect L in perpendicular. So I'm going to write my right angle here. So that one is true. They are perpendicular, so that's not it. So the one not perpendicular is B. I made an obtuse angle. All right, the next one I want you to look at with me. All right, I think you can do these on your own. Is 22, my bad. It says Tim made a polygon. Well, I want to show you. This is how I remember what a polygon is. And you will need to know this for 5th grade. But you should have learned about this a long time. I go like this, okay? Because a polygon has 3 or more sides, and it's a closed figure. So it has 3 or more sides, and it's a closed figure. So Tim made a polygon with only one pair of parallel sides and 2 obtuse angles. Okay, which term describes Tim's polygon? So first it says a parallelogram because there are parallel sides and the largest angle is obtuse. Well, nothing better than to sketch it, right? So a parallelogram is like that tilted rectangle. Okay, this one's acute. This is small, acute, which means the opposite is acute. This one's wide. So this is obtuse, and this one's obtuse. So it does have 2 obtuse angles. Let's take a look at parallel sides. Well, this one is parallel to this one, and this one is parallel to this one. So it has parallel going this direction, and it has parallel going this direction. So that one has 2 pairs of parallel sides, not just one. So that one's not it. A rhombus, because there are 4 equal sides and 4 obtuse angles. Well, let's see. A rhombus, that's a fancy word for a diamond. Okay, so this one is obtuse, really wide, which means this one's obtuse. This one's really small, so this is acute and this is acute. So it does have the 2 obtuse angles, which it said it needed, but let's take a look at parallel sides. Well, this one is going to be parallel with this one. They do not cross. And this line will be parallel with this one. So again, that one has 2 sets of parallel lines, not just one. The next one's a trapezoid. Trapezoid has a short and a long. And then you close and you close. Okay, that is a trapezoid. This is acute, it's angled in. That one's acute, it's angled in. This one's a really wide mouth. This one's obtuse, and this one's obtuse. So it does have your 2 obtuse angles. This is parallel with this two. Those two lines will never cross. But take a look here. This one's angled in. And notice how this one's also angled in. So that's intersecting. So it only does have one pair of parallel sides and has two obtuse. That one is a possibility. And then we have a triangle. Well, this one doesn't have any opposite sides to be parallel. And I don't know what type of triangle to make. And it says because there are parallel sides and two obtuse angles. Well, I know that a triangle, if it could have one obtuse and two acute, but there will always be two acute angles in a triangle. So I know for sure that one's not it. So our answer is H, the trapezoid. Okay, the next one I want you to look at is the final one we'll do together, 24. It's a frequency chart. We like these, frequency tables. The frequency table shows the favorite sports of some girls. The table is missing the information for the number of girls who chose softball, which, FYI, would be my choice. So we have softball, basketball, and gymnastics. The number of girls who chose softball, which we know is missing, is half the number of girls who chose gymnastics. So if I have 36 gymnastics and I know half of it is softball, that means that you and me would have to share. So I would need two equal groups. So we're going to divide this into half, which is the same thing as dividing it into two groups. Well, you can solve it different ways. I could split it into two groups. I could say 10, 20, 25, 30, 31, 32, 33, 34, 35, 36. And I could say there's 18 per group. Or I could take 36 and divide it by 2. How many times does 2 go into 3? 1 time. Divide, multiply. 1 times 2 is 2. Divide, multiply, subtract. 2 times minus 3 tenths minus 2 tenths is 1 tenth. Subtract and bring it down. Okay, now here's our ones. Now we repeat, divide. 16 divided by 2. Well, what times 2 is 16? 8. 8 times 2 is 16. Subtract, there's no remainders. So either way, we know that half of 36 is 18. So 1, 2, 3, 4, close the gate. 5, 6, 7, 8, 9, close the gate. 10, 11, 12, 13, 14, close the gate. 15, 16, 17, and 18 tallies. All right. So the number of girls who chose softball is half the numbers who chose gymnastics, which we found out was 18. How many girls chose gymnastics and softball as their favorite sport? Well, if I want this and that, we need to combine them. So we need to add. So here's gymnastics and here's softball. I located my numbers. So 36 plus 18. 8 and 6 makes 14. 3, 4, 5. So 54. There is your 54. All right, friends, you need to solve the last 12 problems. Then I want you to put the answers to all 24 of these problems in the form I've attached to the day's lesson. Here's the very most important part, though. Listen carefully. After you turn into the form, it will tell you what you got wrong and what you got right. You need to look back at those problems that you got wrong and you need to fix them. Go back to those problems and fix it. The best way we can learn is from our mistakes. You will not be prepared for tomorrow's test unless you go back and see why you missed it. Okay? We're in this together. Let me know if you need help. Thanks, boys and girls.